So those of you who answered B or G in this case, which is the most popular answer, I know, well, I imagine here's what your thought process was. You saw this 8 and you saw it was 5 inches and 40 inches right here. And you immediately were thinking, oh, length times width equals, now in this case, it's area, but you probably were doing something like this in your head. I doubt a lot of you were writing this down, but you probably said 5 times width equals this, and then you divide it, you got the width is 8. Just really quick math in your head. Unfortunately, you got to read through the problem a little more carefully because that is not what you're supposed to do. We're looking at a rectangle, and it's got a width, it's got a length. We're looking for the perimeter, which is if you were able to walk around this, or in this case, it's inches. So if like an ant walked around the perimeter of that paper, how far would it go? And we've got 2 lengths, we've got 2 widths. So the overall perimeter length is going to be 2 times the length plus 2 times the width, and that's your perimeter. All right, so you can see there's 1, 2 widths, 1, 2 lengths. All right, the perimeter, it tells me, is 40 inches. So I'm going to substitute that in. I don't know what the width is. That's what it's asking me to find. But it does tell me that the length is 5 inches longer than the perimeter. So I'm going to erase some things here to make this not look so cluttered. All right. So looking at this now, I want to look at this first sentence. The length of a rectangle is 5 inches longer than the width. Think of this is as an equals sign. The length of a rectangle equals 5 inches longer than the width. So length is equal to the width plus 5. So what I'm going to do is, if I can convert that into an equation like that, I'm just going to substitute W plus 5 in for length. So 2 times W plus 5 plus 2 times the width. Now, with that one step, and I know that's a little bit tricky, but with that one step, I can now just solve for W. I'll use my distributive property. I'll actually bring this up here now. So if I do distributive property, it's going to be 2 times W plus 10 plus 2 times W equals 40. I can combine my like terms. I get 4W equals 10, or sorry, plus 10 equals 40. Subtract your 10 from both sides. I'm going through this part pretty quickly now. 4W equals 30. And W equals, at this point, you plug that in your calculator most likely. Maybe you can do it in your head. That's 7.5. So your width is actually 7.5 inches. So there's a little bit more to it. Sometimes you need to read through the problem a few times in order to wrap your head around it. So on Thursday, we introduced our very first rules. The very first rules that we had were the rules that were vertical angles. We had linear pairs. We had angles on a line. Sorry for my writing, it's not very easy to read. And then angles at a point. And then we had this other one, I'm going to put in parentheses, the angle addition postulate, which we really won't use very often, but it is one that we learned. So we learned those on Thursday. All right, and then on Monday, we learned our new rules, which really there's just 3 of them. We had corresponding angles. We had same side interior / same side exterior. I'll kind of combine both of those together. And then we had alternate interior and alternate exterior angles. So if you can look at all of those names and you can kind of visually imagine what all those angle relationships look like, you're in a good spot right now. If you don't know what I'm talking about when I say angles at a point, then you need to go back, watch the video from Thursday and do the practice and anything else that you might need to do. So anyways, these are the rules we currently have down. And I'm going to put up, there is currently a reference sheet available on the Canvas page, but I think I'm going to create another one to put up there that'll kind of, that will help clarify that even more. Today, we're going to learn our last batch of rules, which are the triangle rules. And we're going to start just by talking a few things about triangles in general. Right. So let's go ahead and jump into this. All right, so a lot of this stuff doesn't matter a great deal. Well, I don't want to say it that way. What I mean is some of the stuff we're not actually going to worry about these terms. And it does matter that a scalene triangle has no equal sides. So you learned about that in years past. But we really don't talk a lot about scalene triangles, even though they're the most common ones we're going to see. Isosceles and equilateral triangles, these are going to be important things to remember. In fact, isosceles, we're going to talk about both of these types in just a minute, but isosceles, sometimes that's one that students forget. If it has two equal sides, it's isosceles. All right, so don't forget that one. The right triangle, this is probably going to be one of the most important triangles that you are aware of, because not right now, especially, but in a few weeks, I don't know what that means. It's going to be after spring break, I think. But we're going to be focusing on right triangles for quite a while. And so that's going to be a very important part. These right here are important. The others, the scalene, acute, and obtuse, those are definitely terms that are out there and you might see them, but they're not going to show up a great deal. And I should point something out. Obtuse means that the angle is greater than 90 degrees. And so we've got that right there. This acute triangle is not actually acute. They picked a bad example because this angle is more than 90 degrees. That's actually another obtuse triangle. So this one right here is acute. So it's a subtle thing. But anyways, it's worth talking about it. And maybe one other thing we can talk about real quick before we move on to the next page is how we name triangles. So if I take this obtuse triangle down here, and this is, I'm going to put A, B, and C right here. If I wanted to name that triangle, the notation I use looks like this. I just put a small triangle and then A, B, C. It doesn't have to be called triangle ABC. I could call this triangle BCA if I wanted to. I could call this triangle ACB. You get the idea. There are actually 6 different names for this triangle. So I'll just give one more, triangle CAB. All right, we could pick 2 other names for this triangle, but all that matters is if I start here at A and I work my way around, it goes A, then B, then C, then back to where I start. That's how we name the triangle. And I can pick any starting point and go in any direction. So that's why we have 6 different names. Okay, so that's just important to understand this notation. And if you have questions about it, you can speak up or let me know. Wait just a second. So let's look at the next screen and all right, sorry about that, just sending a message. Okay, so we've got 2 rules right here. And like I said, I'm going to put up another reference that's a little bit more to the point. This has a lot of writing in here that, I don't want to read that. You probably don't want to read that. Though it does kind of explain it if you do read it. Sometimes it's not as clear cut. So anyways, we're going to start with this rule right here that says essentially that this angle A plus this angle B, and we're looking at any triangle, okay? This is not a specific triangle. Any triangle that you can draw, this rule will follow. All 3 of the angles that make up a triangle have to add up to, you can see right there, 180 degrees. So that is probably our most important rule for triangles. And this is what we call the triangle sum theorem. So I'm not writing very well. And the abbreviation we're going to get to that is TST, triangle sum theorem. I don't know what more needs to be said except that it doesn't matter what triangle you're looking at. So if I had a triangle that would look like this, all right, now that's a very different looking triangle, yet still all of these angles right here, this angle now is very big, but these two angles have gotten very small as a result. So this is still going to add up to 180 degrees. And then the kind of triangle that we typically see, no, not typically, but that we will see a lot, okay, that doesn't look very good. Let me try and draw a better one. There we go. So we'll call that one a right triangle. These three angles will also, so the right angle and these two have to add up to 180 degrees also. And that means in this special case, when we have 90 degrees right here, that these two angles have to add up to 90 also. So that just says 90 degrees combined. All right, so just a few things to keep in mind, but general rule, very important, the triangle sum theorem. All right, the next one, this one is kind of different. All right, so I'm going to start by finding all these angles that it's talking about. So it says the measure of angle BAC, BAC, so I start at B, come down to A, over to C, so it's this angle right here. So that angle plus angle ABC, I come over to this one, that's that angle right here. Those two are equal to angle BCD, which is this one right here. You can see the BCD. Middle point is always the vertex, okay? That's how we name angles. So this rule tells me that this exterior angle, and notice that in the writing over here, this is called an exterior angle, and it's on the outside of the triangle, so that makes sense. So this is our exterior angle. That exterior angle is going to equal the two opposite interior angles. So it sounds like we're throwing out a lot of new terminology, but this is the interior angle that's adjacent. So the opposite interior ones are going to be the ones that are as far away from that point as you can get, or just the other two. So if it's not the adjacent angle, then it's one of the opposite interior angles. All right, so those two angles, the blue and the red one there, have to add up to equal the exterior angle. And there it is. So this has this long name, exterior angle of a triangle, but notice exterior angle of a triangle. Hey, we formed an acronym here, EAT. All right, so if you want to talk about this, if you want to say why we're using, or why you set up your equation the way you did, you can say this is because this is the exterior angle of a triangle. All right, and we're going to get some practice with these two rules today. And the next two that we're going to look at, we're actually not going to practice with them today. That's going to be tomorrow's work. All right, any questions on this before we move ahead? And while I'm waiting for that, if you wanted to take a picture of this, you could do a screenshot of it if you think that'll be helpful for you. All right. So I'm going to move ahead. I'm going to clear the screen now, assuming everyone has had a chance to take a picture if they wanted it. We have two other rules. And like I said, these two we're not actually practicing with today, but I'm going to give you guys some extensive practice with this tomorrow. And it'll probably include all of the angles we've learned up to this point. So these are the final two rules that you need to learn and understand. So luckily we started by talking about what an isosceles triangle is, and we can see that these two sides right here are congruent. When you draw a dash through it, that's showing that those two sides have the same length. All right, so the base angles are the ones down here. When you look at the third side that's not congruent, the two angles that connect to that are called your base angles. And these base angles are equal. So if I called this one angle A and this one angle B, then I could say the measure of angle A equals the measure of angle B. And that's all there is to it. And if I gave you different expressions to put in right there or different numbers, you could just substitute those numbers into that equation. But we know that they're congruent. Now, the shorthand we have for this, notice we have base angles of an isosceles triangle. Hey, we've got another acronym coming our way. Base angles of an isosceles triangle. This is kind of the shorthand you can use for that one. Again, we will be practicing more with this, so I highly encourage you guys to kind of just conceptually wrap your head around this and then be prepared tomorrow to try it with some real problems. All right, the last one doesn't actually come up very often. Occasionally it can, and this is your equilateral triangle. All three sides are equal in length, and they all have equal measures. So if this is A, B, and C, the measure of angle A plus, or not plus, sorry, equals the measure of angle B, which equals the measure of angle C. Now, knowing the triangle sum theorem that says all these angles have to add up to 180, if all these angles are equal, what is the angle measure?
60.
60 degrees. All you have to do is take that 180, this doesn't show up very clear against that blue, divide by 3 equal angles and we get 60 degrees. Hopefully that's shown up clear enough. All right, so this, I don't have a fancy acronym except we can just use EQ for equilateral and then triangle. So I will let you guys take a picture of that if you want, if you think it will be helpful. And then we're gonna go and see what our practice looks like for tonight. And when I say tonight, you can actually get started on it pretty soon. So I'm gonna go ahead and erase this. If any of this does not click for you today, it's important that you hang around, we can talk about it more. But now raise your hand, let me know you're here. So your homework tonight is gonna be on Delta Math, and the assignment is just called Triangle Angle Rules, which sounds a little bit redundant, but it's just gonna involve 2 of the rules that we learned today. And now I'm gonna move over to Delta Math so you can see what that's gonna look like. All right, so you're gonna have 3 different parts of your homework tonight. The first one's gonna look like this. It's rather straightforward, and we've got one unknown angle right here, and then 2 angles that are given. So this is gonna be where we use one of the rules that we learned. Can anyone tell me what the rule that's gonna apply here is gonna be?
All those angles should add up to 180 degrees.
There you
So
go.
you just got to figure out what the third is by adding or subtracting.
Perfect. Great explanation. We do have a shorthand name for this. If you want to remember, that's called TST. That's a triangle sum theorem. And just like Connor was saying, now we can just add these together. X plus 42 plus 113. It has to add up to 180. So I know what the right side of my equation is for every one of these. And this is pretty straightforward. I can combine like terms. So I'm going to get X plus, and I expect you guys to use your calculator. I'm just going to do this a little bit quickly. So when I add this together, I'm going to get 155. Now, if I am moving too fast and you're not sure how I'm going from step to step, then certainly let me know. We can go through another one. I'll go slower, or I can, we can kind of, we'll make sure that you get what you need. Okay. So now I want to get X by itself. So that means subtract 155. And when I do that, all I'm left with on the right side is 25. So my missing angle right here should be 25 degrees. I'll submit my answer, and it turns out we did it right. It gives the explanation for how to do it in case you get it wrong, or even if you get it right, it'll tell you. So just to make sure if like you accidentally guessed correctly, now you can actually see what you did. Did you have a question? See a hand raised. Okay. So I was just going to do one of these because it's going to be more the same. If I pull up a new problem, it's just going to be similar. x with two angles given. So you'll get some good practice with your triangle sum theorem. The next one gets a little bit more complicated because we still have two angles that are given, but now it's not just x, it's an expression. Luckily, this does not change things too much. This is still triangle sum theorem. If you have two angles and you're solving for the third, it's always triangle sum theorem. But now it's going to be this. This is, of course, 90 degrees. So I'm going to start setting this up. I've got 90 degrees plus 57 degrees. Notice I'm just getting that from the triangle here and here. Plus, and instead of just putting x, I have to put this entire thing plus 7x plus 19. And this all adds up to 180 degrees. So that's the only difference here. Our equation solving gets slightly more complex, but not by much. So now I want to add up all my number terms. 90 plus 57 plus 19. All right, so these, I'm going to go ahead and erase these parentheses right here. So it essentially is going to look like that. And so if I do that, let me see, that's 166. Oops, sorry. Plus 7x equals 180. But you could just take your calculator, add all these up, and see what you get. Now, if I do my subtraction, I want to get this x by itself. So the first thing I'll do is subtract 166. And I get 7x equals 14. And now I can just divide both sides by 7. X equals 2. So we will confirm that that's correct. And it gave me the green check mark. We did it right, but you can come down here and you can see how to solve that in case you did it incorrectly. All right. So very good. Those are your first two tasks on the homework, and you're gonna have to do 5 more problems like this. Again, if you need to see another one, we can do that. I'll just show you. Here's another problem where it's gonna be basically the same setup, but now we have an expression given rather than just an x. So the last part of your homework is looking at exterior angles. All right, and I'm glad we start with this one, because our second rule that we learned told us that if we have an exterior angle right here, then here's kind of the linear pair that's made with it. But the interior angles that we're concerned about are the two that are opposite. All right, so those two, the rule tells us basically that our exterior angle, 80 degrees, is going to equal x plus 25 degrees. It's these two angles right here added together. So this is kind of just a miniature shortcut, helps us save a little bit of time. But you can find this can be very helpful. All right, so if that part makes sense, it's a very simple calculation. So I'm going to subtract 25 from both sides. And x here equals 55 degrees. So I will plug that in, 55 degrees, submit my answer. And it looks like we got it right. Now, they solve it a little bit differently here. So if you follow their work, it doesn't look exactly like ours, but we use that rule, exterior angle of a triangle, which helps make it work a little faster. But anyways, you can follow through their work if you need to see how they do it. They set up and solve for this interior angle first with linear pairs. And then they use the triangle sum theorem for all 3 interior angles. So they would first solve, if this is 80, this has to be 100, and then 100 plus 25 plus x have to add up to 180. So no matter which way you approach this problem, you'll get the same answer. All right. Now I wanted to pull up another problem. Okay, and this one works out really well. Because notice that our x right here is not one of the opposite angles. It's actually, we don't care about those angles. So for this particular problem, I can ignore the rest of this diagram and just focus on this. And what would you call this angle relationship? I've already used the term, but what would you call that angle relationship? This is whenever you have two angles, two adjacent angles that form a line. What do you call those two angles?
Linear pairs.
You got it, linear pair. So I'm just going to put LP right here. So that's just something to keep in mind. For some of these problems, we don't even need to do anything fancy. It's just going back to what we learned on Thursday, linear pairs. And so that just means that these two angles, x plus 125, have to add up to 180 degrees. And now that's really quick math. You guys can probably do that. I'm actually just going to leave it there. But if you have any questions about this, please stick around. And if you are good to go, then you can go to Delta Math. You can practice with this. I encourage you, if you struggle with the Delta Math or any homework and you have questions, come back to class the next day and ask, and we can go over more of this stuff. If you're getting it all, it's making sense, very good. But I will stop talking at this point. Have a wonderful day. If I ask you to stick around, please stay. But besides that, if you don't have any questions, I will see you tomorrow.